In the last video, we evaluated integer exponents and our answers were numerical. In this video, we will be looking at simplifying integer exponents, which means we will be dealing with variables. So let's just take a minute and review negative exponents. How do you change them to positive? Remember, you take the reciprocal of the base and you change the sign of the exponent. So if you have a fraction, leave the fraction. Anything that has a positive exponent, leave it where it is. And if it's negative exponent on top of a fraction, it comes to the bottom. And remember, the reciprocal of x is 1 over x. And here we have a negative exponent on top, so it needs to come to the bottom to make it a positive exponent. And if it's on the bottom, it needs to come to the top. Let's just take a minute and review that 0 exponent. What's anything raised to the power of 0 is 1. So we have all of this raised to a power of 0 is just 1. So sometimes that can just sneak up on you and you kind of forget, but remember, a base except for 0 raised to the power of 0 is 1. Now let's look at the problems, what we're going to do. We're going to simplify, which means our answers will not just be numbers. But the key thing is your answers should not have any negative exponents. So as I look at problem number 1, I see, wow, lots of bases, lots of exponents. And so I'm going to kind of follow these 3 steps. These are not rules, these are just experience talking. I think this is the easiest way to not make mistakes. So if you have parentheses, I'm going to multiply the exponents to get rid of the parentheses. Because remember, if you have a power raised to a power, you multiply. Remember, if you have x squared to the 3rd power, keep the base and multiply those exponents. So that's what I'm going to do here. Now the most common mistake is forgetting that the numbers also have an exponent of 1. So I'm going to multiply all those exponents and keep the base. So I have 3 to the 2, x to the negative 4, y to the negative 6. And I'm going to do the same thing on each of those, multiplying that out. So I have 5 to the negative 3, x to the negative 3, and y to the positive 3. The next thing I'm going to do is I'm going to make all the exponents positive. So let's see, that one's negative, 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 but the other ones that I've not circled are already positive. So I want you to think about this all being over 1, one big happy fraction. So I'm going to keep that fraction. If it's positive exponent, it stays where it is. But all those negatives need to move to the bottom. So I'm going to have x to the 4th, y to the 6th, 5 to the 3rd. I'm just going to put that in front because that's kind of where numbers go. And I have x to the 3rd. The 3rd step is I'm going to clean that up. Simplify. What's 3 squared? That's 9. What's 5 to the 3rd power? 125. Now what else can we do? Well, those are the same base. So if you have the same base and they're multiplied, you add the exponent. So this is going to be x to the 7th power. But here I have this y and that y. So I have the same base. They're being divided, so the rule is keep the base and subtract the exponents. But before I just start subtracting, I want to know which way do I subtract. Well, 6 is bigger than 3, and because I don't want to have any negative exponents, I always want to take the biggest minus the smallest. And since there's more y's in the bottom, I'm going to leave that base in the bottom and then subtract 6 minus 3, and that gives me a positive 3. Another way to remember that, if you have y to the 3rd power on top and y to the 6th power on the bottom, that's what you would have, and you would reduce, you would have y to the 3rd power on the bottom, and that's where that rule comes from as far as subtracting the exponents. So this is my final answer. I don't have any negative exponents. Everything is as simplified as I can possibly be. Right, looking at number 2, I have a fraction, lots of parentheses, things like that, so I'm going to use these same 3 steps. Again, not a rule, it's just the way I do it. All right, so I'm going to remember that there's ones there, and I need to multiply those exponents. So I'm going to have 3 to the negative 2, x to the negative 10, y to the positive 8. Then I'm going to take that 3, so I have 2 to the third power, x to the negative 6, and y to the negative 9. So again, I'm just multiplying the exponents to get rid of the parentheses. The next thing I'm going to do is I'm going to make all the exponents positive. So I have a fraction. Everything that's positive stays. So that one stays, everything else moves. So I'm going to leave that y to the 8th, and I'm leaving 2 to the third power. So 3 to the second power goes on the bottom. Remember, I'm taking the reciprocal of the base, changing the sign of the exponent. X to the 10th moves to the bottom. X to the negative 6 moves to the top, and the y to the negative 9 moves to the top, and all those exponents become positive. Now I'm going to clean it up. So what is 2 to the third power? That's 8. And 3 to the second power is 9, and those are being multiplied, so that's 72. What else can I see? Well, I have some y's that are being multiplied, so I can keep the base and add the exponents. Then I have those. Same base, divided, so the rule is keep the base, subtract the exponents. But just like on the previous example, where are there more? As in, who has the biggest exponent? On the bottom. So I'm going to keep the x on the bottom and subtract 10 minus 6, which is 4. Final answer. Doesn't have any negative exponent. Everything is as simplified as possible. Let's look at this third example. So now we have one big parenthesis. So that means this exponent doesn't just affect the top, but it also affects the bottom. So that 2 goes to all of those. All right, so I'm going to have 5 squared x4 y to the negative 10 over 8 squared x to the 12th and y to the negative 24th. So I got rid of my parentheses. Now I'm going to make all my exponents positive. Well, the good news is that those are the only ones that are negative. That's the only things that need to move. So I'm going to have 5 squared x to the 4th, 8 squared x to the 12th. The y to the 24th comes on top. The y to the 10th comes on bottom. Now I can clean it up. So 5 squared is 25. 8 squared is 64. I have the same base there. There's more x's on the bottom, so I'm going to keep the x on the bottom and go 12 minus 4 is 8. Those are the same base, but this time 24 is bigger than 10, so my base is going to go on the top, and 24 minus 10 is 14. So again, we're using rules that we should already know and applying them to the negative exponents. One last example. Very similar to the last one, we have one big set of parentheses, but this time that exponent's negative. It's going to go to all of them, and we also have that 0. So let's just start with multiply the exponents to get rid of the parentheses. So we have 6 to the negative 3, x to the negative 9, y to the positive 6. 9 to the, now negative 3 times 0 is still 0. We have x to the positive 15th and y to the positive 18th. Now I want to make all my exponents positive. Well, let's see. This one's negative, that one's negative, but everything else is positive. But what are we going to do with this? What's anything raised to the power of 0? That's a 1. That's 1. All right, so we've gotten rid of some stuff. So things I've circled here, 6 cubed goes on the bottom, x to the 9th goes on the bottom, but everything else stays where it was. So I have y to the 6th, x to the 15th, and y to the 18th times 1. So when you multiply by 1, you just get back what you started out with. So 6 cubed, I believe that is 216. Let's see, that's 36 times 6. Yep, that's 216. Okay, then I have those are the same base. They're being multiplied, so keep the base and add the exponents. Then those are the same base being divided, so I keep the base. Subtract, but that one's bigger, so that one's going to stay on the bottom. 18 minus 6 is 12. Am I done? Does that really look right? Can you have a fraction with just nothing on top? No, we need that 1. Because remember, when we're taking those reciprocals way back there, that's really 1 over 6. This is really 1 over x. So there is a 1 there. So don't leave a fraction with just nothing on top. So again, the steps I follow: I multiply the exponents to get rid of the parentheses, use that power to a power. I then make all my exponents positive, and then I do my simplifying, like 6 to the third or 5 squared. Again, that's not a rule, that's just a process that I think will help you make less mistakes.